If the number of rows is not equal to number of columns, then the problem is said to be an unbalanced assignment problem, whereas in second column 0 is the minimum value. If you subtract 0 from any number, you will get the same number. Zeros covered is equal to the order, then the problem is optimized. Hello dear students, welcome to this session of OR Operation Research class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College. In my previous class, we have discussed the problems based on assignment. Now in this session also I am going to take one more problem based on the assignment, and now let us discuss the unbalanced assignment problems. Now so far we have discussed a balanced assignment problem. Now let us take one example regarding unbalanced assignment problem. In an assignment problem is said to be an unbalanced if the cost matrix is not a square matrix. If it is not a square matrix of order m into n, the given matrix is of not square matrix, that is the number of rows is not equal to number of columns, then it is called a unbalanced assignment problem. So the number of rows are not equal to the number of columns. Such a problem is called an unbalanced assignment problem. So to solve such type of unbalanced transportation assignment problem, we are going to use a dummy. We are going to take a balance by adding a dummy row or a dummy column with all the entries as zeros. So we are going to add one dummy row or dummy column with all the entries as 0 and 0. So here, if the number of rows is not equal to number of columns, then the problem is said to be an unbalanced assignment problem. So to convert this unbalanced assignment problem, we are going to add a dummy row or a dummy column with all the elements as 0, 0, 0. Okay. Now let us start with an example. Now let us come to this. 3 jobs are to be done by 4 machines. So here 3 jobs are done by 4 machines. Each jobs can be assigned to one and only one machine. The cost of each job on each machine is given in the table. Now we have to find the least cost for this. Okay. Now the 3 jobs are done by 4 machines. So there are 3 jobs, J1, J2, J3, and the machines are M1, M2, M3 and M4. So 4 machines will perform 3 jobs. Then the cost of each job on each machine is given in this table. Now we have to calculate the least cost for this. Now this can be solved using the same method which we have solved like in Hungarian method. So just find out the row minima, column minima and go for row scanning and column scanning. If the number of rows or number of columns is equal to number of lines drawn, if the number of lines drawn is equal to the order, then we are going to say it is balanced. We will find the optimality, right? Now first let us check whether this is a bounded, this is a balanced or unbalanced problem. Now what is the order here? So this contains 3 rows and 4 columns. So the number of rows is not equal to number of columns. Here first row, second row, third row, first column, second column and third column. So therefore this is an unbalanced assignment problem. Unbalanced assignment problem. Now this can be balanced by adding a dummy row or a dummy column. Since this contains 3 rows and 4 columns, we are going to add one dummy column, dummy row. So if we add one row, then this becomes 4 cross 4. Here we are going to take all the elements as zeros. Okay. Now let me come to the next page. Let me do the row minimization here itself. Now let us come to row minima. Row minimization. So we have here M1, M2, M3, M4 and similarly the jobs J1, J2, J3 and J4. Okay. Now let us find out the row minima here. So here the minimum value is 18 is the minimum value. Subtract each and every element by 18. 18 minus 18 is 0. 24 minus 18. 24 minus 18 is 6. Again 28 minus 8 is 10. And 32 minus 18 is equal to 14. Okay. Now let us come to the second row. In the second row, the minimum value is 8. So subtract each and every element by 8. 8 minus 8 is 0. 13 minus 8. 13 minus 8 is equal to 5. Then 17 minus 8. 17 minus 8 is 9. 19 minus 8 is 11. Okay. The minimum value is 10 in the row 3. So 10 minus 10 is 0. 15 minus 10 is 5. Again 15 minus 10 is 5. Again 22 minus 10 is 7. So here all the values are 0, 0, 0 and 0. Okay, this is called a row minimization. Okay, let me check here. Let me go to the last row. In the third row, minimum value is 10. 10 minus 10 it is 0. 15 minus 10 is 5. Again 15 minus 10 is 5. 22 minus 10 is 12. Okay, last element, all the elements are 0, 0, 0 and okay. Now, similarly, let us go to the column minimization. So, from this, we are going to do column minimization from this. Now, let me do column minimization. Now, same here. Let us consider the same matrix. Now, here this is M1, M2, M3, M4 and here these are J1, J1, J2, J3 and J4. Now let us come to column minimization. So let us come to the first column. So in the first column all elements are 0, we can write 0, 0, 0 here. In the second column minimum value is 0, we will have the same 6, 5, 5, 0. In the third column also same values, that is 10, 9, 9, because once if it is 0 means if you subtract any number from 0, if you subtract 0 from any number you will get the same number, so it will remain the same, it won't changes. So row minima and row column minima both values are found to be same here. Now after finding row minima and column minima, let us come to the scanning, row scanning and column scanning. So I will write these elements here. Now, let us come to the row scanning. So, in the row scanning, what are the elements we have? 0, 6, 10, 14, 0, 6, 10, 14, again 0, 5, 9, 11, 0, 5, 9, 11, again 0, 5, 5, 2, 0, 5, 5, 1, 2, 1, 2. Then the last row 0, 0, 0, 0. So, now, this is row scan. Let us come to the row scanning now. So, in the first row, identify the zeros here. So, these are 1, 2, 3 are nothing but, this is nothing but M1, M2, M3, M4. These are the jobs J1, J2, J3 and J4. Now, just find out the 0 here. The 0, let us mark this 0. And once if at all any 0 in the first row, cancel the entire column. This column is cancelled. So we can cancel this column. Right. Now let us come to the second row. In the second row there is no 0, whereas in the third row also there is no 0, and whereas in fourth row we have 3 zeros, we can skip this. Now let us come to the column scanning. In the column scanning, I will write the elements here 6, 5, 5, 0, 10, 9, 5, 0, again 14, 11, 12 and 0. So this row we have cancelled, that is this is cancelled, that is M1 is cancelled. Now identify the, now let us come to the column scanning. In the column scanning, in first column is cancelled. Now come to the second column. In the second column we have 1, 0. So this is 0. Now we can cancel this entire row. And come to the third column. In the third column there are no zeros, and even in the fourth column also there are no zeros. Now identify the number of lines drawn. So the number of lines drawn, this is one line, this is the first line and this is the second line. So the number of lines drawn are 2. Number of lines drawn So number of lines drawn are 2 lines. So, okay. Now here what you say, the order is equal to 4. Since order is equal to 4 and the number of lines is equal to 2, therefore 2 is not equal to 4. Okay, right. Now since the order is not equal to the number of lines we have drawn, so therefore we have to go for the next step. What is the next step? Identify the least uncovered values. Which is the least uncovered value here? Here 5 is the least uncovered value. There are 3 values. You can choose any value, any one least uncovered value as 5, right? Let us call it as x is equal to 5. X is the least uncovered value. We can choose this x is equal to 5 as the least uncovered value. Now subtract all the elements, all the uncovered values by 5, and at the intersection of the lines, so these are the intersection of the lines, here you are going to add 5, plus 5 we are going to add, and at the remaining values we can subtract. Okay, now let me write the chain. Now the next will be like this. This is yes, m1, m2, m3, m4, j1, j2, j3 and j4. Okay, now let me write down these values first. So just I am going to add 5 here and the remaining are same, 0, 0, 0. If I add 5, we will get 5 here, and any intersection of diagonals, intersection of the lines, only this point is the intersection, and these are all 0, 0, 0 as it is. Okay. Now then subtract each and every element by 5. 6 minus 5 is 1, then 10 minus 5 is 5 again, then 14 minus 5 is equal to 9. Now let us come to the second row. Here 5 minus 5 is 0, 5 minus 5 is 0, 9 minus 5 is 4 and 11 minus 5 is 6. So this is 0, 9 minus 5 is 4, then again 11 minus 5 is equal to 11 minus 5 is 6. Again next value 5 minus 5 is 0, then 5 minus 5 is 0, again 12 minus 5 is equal to 7. So this is the modified table here. Now go for the scanning. Already we have marked the zeros in the previous table. Where you have marked zeros, this is 1 point. Okay, now let us go to the scanning now. Now let us go to the first row scanning. So this is 0. Let me write this. So once if this is row 1, in row 1 where you have 1 0, once if 0 is marked, we can cancel this column. So column 1 is cancelled, m1 is cancelled. Now go to j2. In the j2 we have 0 here. Once if it is marked, we can cancel this. Again in j3 we have 0 here, so you can cancel this, and in j4 we have 0 here, we can cancel this also. Since all the rows are cancelled here, all the columns are cancelled, so the number of rows and the number of columns are 4. So here number of rows and columns is equal to 4, and the number of lines drawn are also equal to 4. That means it is balanced here. So the number of lines drawn is 4 and the order is also 4, hence the solution is optimal and it is feasible. We can find the feasible solution. Now to find the feasible solution, let us go to this. J1 can perform the job with machine M1 and J2 can perform the job with machine M2, and whereas J3 will perform the job with machine M3 and J4 will do the job with the machine M4. Right, M1, M2, M3 and M4. J1 to M1, J2 to M2, J3 to M3 and J4 to M4. Now just substitute the values. So what are the values we are going to get here? Now come to the initial problem. So J1 to M1 is 18. J1 to M1 is 18, J2 to M2 is 13, J3 to M3 is 15 and J4 this is a dummy, that is 0. 18, 13 and 15. 18 plus 13 plus 15 will give the answer. 18 plus 13 plus 50 plus 0. That's it. So if I add this, what you will get? 5 plus 3, 8 plus 8 is 6. 1, 1 plus 1, 2 plus 1, 3 plus 1 is 46. So therefore the total cost of the job is rupees 46. That's it. The total cost is equal to rupees 46. That's all. This is how we are going to solve an unbalanced, unbounded assignment problem. So hence the total cost of the job is 46. This is how we are going to solve a problem. Hope you followed this. This type of problems are very, very important for the point of examination. Hope you may get this type of question either for 7 marks or 8 marks. Now let us come to the next important concept, TSP, Traveling Salesman's Problem. This is also a very important concept. In the examination, you may expect a question on this. Otherwise, step-by-step procedure to solve a traveling salesman's problem. So here, traveling salesman's problem, TSP, is also a method of assignment problem. This is also an assignment problem in which we have to make the decision about the assigning the task to the salesperson. So just assigning a particular job for a particular salesperson. So the task of assigning a job for a particular salesperson is nothing but the traveling salesman's problem. Now here, under traveling salesman has to visit different cities only once, but they have returned to their starting point. So he should have to visit the place only once. After visiting, he has to return to its same original position. This is the important criteria here. So the transportation, that is the traveling salesman's problem. Traveling salesman's problem is another method of assignment problem in which we have to assign, in which we have to make the decision about assigning the task to the salesperson, and a traveling salesman has to visit the different cities only once. After, he has to return to his starting point, that is the original place. Now, how to solve this? The step-by-step procedures to solve or to formulate the traveling salesman problem as an assignment problem is as follows. What are the steps? Now, step number 1. A traveling salesman can plan to visit in the n cities. Suppose if you want to visit the n cities, he wishes to visit each city only once. Suppose if you want to say visit number of cities, 4 cities, you have to visit one city only once. After visiting, you have to return to the same original place. The traveling salesman plans to visit n cities. He wishes to visit the city each only one time. Now, after visiting, now go to the second step. What is the next step? And again arriving back to his home city from where he started, so that the traveling distance is minimum. So after visiting the particular city, he has to come back to the same place, hometown, in order to minimize the traveling distance. So to minimize the traveling distance, he will come to the same place. Now after that, if there are n cities, then there are n minus 1 factorial possible ways. Suppose if there are n cities, then the number of possible ways are n minus 1 factorial. Suppose for example, let us consider there are 4 cities. He has to visit, if the number of cities to be visited is 4, then the number of combination will be 4 minus 1 factorial. 4 minus 1 is nothing but 3 factorial is 3 into 2 into 1 is equal to 6 ways. So he can travel in 6 different combinations. So he can travel in 6 different combinations. So these are the 6 possibilities. Such type of problems can be solved by the penalty method. So this can be solved using the method of penalty. Now, how to solve the problem? Solve the problem as an assignment problem. Now, just what are the steps? Check for a complete cycle of alternative cycle or alternative cycle. If the cycle is completed, then go for the next. So just penalty method we are going to use to solve this method. So as we have solved so many problems in penalty method, then check the complete cycle or alternative cycle. If the cycle is completed, then we have to go for the next step. So to start with, assign the next least element other than 0 and complete the assignments. Finally, write the optimum assignment schedule and calculate the cost or the time of the given problem. Okay, so these are the few steps which we are going to follow while formulating the problem as well as while solving the given assignment problem. Salesman's problem, that is nothing but an assignment problem. Now let us come to an example. Now let us take an example. Find the least cost route. What is to determine? Find the least cost route using traveling salesman's method. Find the least cost route. Least cost route is to be determined using the salesman's method for the given problem. What is the problem given? So A, B, C, D are the cities. This is the condition given: infinite, 46, 16, 40, 41, 8, 50, 40, 82, 32 is infinity, 60, 40, 40, 36 and infinite. Now just to solve this problem, we are going to use the same steps like which we did in the previous problem. Just find out row minimization, then column minimization, and go for row and column scanning, and draw the number of lines. If the number of lines is nothing but here the number of assignments is equal to the order of the given matrix, then the problem is feasible and we will have a feasible optimal solution. Otherwise, we have to proceed with the next step. Now, let us find out, let us come to the row minimization. Here the minimum value is equal to 16, subtract each and every element by 16. Next, here the minimum value is equal to 40, subtract each and every element by 40. Here the minimum value is equal to 32, subtract all the elements, each and every element of this row by 32. Here the minimum element is 36, subtract each and every element by 36. While doing the column scanning, identify the least value and subtract each and every element by that particular least value. Now let us come to the row scanning first. In the row minimization, infinite, the least number is 16, 46 minus 16 is 30, 16 minus 16 is 0, 40 minus 16 is equal to 24. So we will get infinite, 30, 0 and 24. Now let us come to the second row. In the second row, the least value is 40, 41 minus 40 is 1, infinity as it is. Then again 50 minus 40 is 10, 40 minus 40 is 0, 10 and 0 is the second row. And in the third row, what is the minimum value? 32. So 82 minus 32, 82 minus 32 is equal to 50, and this 32 minus 32 0, infinite. Again 60 minus 32 is equal to 28. And in the last row, the minimum value is 36, 40 minus 36 is 4, again 4, 0 and infinity, 4, 4, 0 and infinity. Let us come to the column minimization. Here the minimum value is equal to 1, subtract each and every element by 1, infinite minus infinite as it is, 1 minus 1 is equal to, this is 0, again 50 minus 40, now 1 is 49, 4 minus 1 is equal to 3, this is 3, right. Now I will write here, now I will go to this column minimization. Okay, now let us come to the row minimization. This is A, B, C, D. So A, B, C, D. Okay, now row, this is infinite, least value is 16, 46 minus 16 is 30, then 0, 40 minus 16 is 24. Next, the minimum value is 40, 41 minus 40 is 1, here I will write 1, then infinite as it is, 50 minus 40 is 10, 40 minus 40 is 0, here the minimum value is 38, 82 minus 32, 82 minus 32 is 50, 32 minus 32 is 0, this is infinite, and 60 minus 32 is 28. Now the last, 36 is the minimum value. 40 minus 36 is 4. This is 4, 4, 0 and infinity. These are the values we are going to get. After row minimization, let us go for column minimization. In column minimization, if we come to the first column, minimum value is 1, subtract each and every element by 1. Whereas in second column, 0 is the minimum value. If you subtract 0 from any number, you will get the same number. Here also 0, here also. So that means B, C, D will remain the same. Only this will changes: infinity, 0, 49 and 3. Now let me go to the next, that is column minimization. In the column minimization, what I will get? Infinite, 0, infinite, 0, then 49 and 3. 49 and 3. The remaining values are same as usual. What are the values we have? 30, infinity, 0, 4. 30, infinity, 0 and 4. Whereas 0, 10, infinity, 0. 0, 10, infinite and 0. And the last D, 24, 0, 28, infinity. 24, 0, 28 and infinite. These are the values. Okay. Now let us come to the this is column minimization. Now after column and row minimization, go to the scanning. We can go for row and column scanning. Let us go to row scanning. Let us come to the first row. The first row, just identify the number of zeros. Here there is 1 0. You can mark this 0. Once if I mark the 0, and you can cancel this particular column. This column is cancelled. Now come to the second row. Second row we have 2 zeros. Then go for the next row. In the third row we have only 1 0. So mark this 0 and you can cancel this particular column. Then in the fourth row we don't have any 0. Now this is called the row scanning. Now let us come to the column scanning. In the column scanning, just identify the zeros. Here in the first column we have 1 0. Once if you identify this as 0, you can cancel this particular row. This is cancelled. Again in the second row, second column as well as third column is already cancelled. In the fourth column we don't have any zeros. Now just count the number of lines which I have drawn. The number of lines drawn: first line, second line, and this is the third line. Number of lines drawn. Number of lines drawn is equal to 3, whereas the order of the matrix is equal to 4. 3 is not equal to 4. So this is not balanced. This is not optimized. Okay. So this is the solution is not optimal. So because the number of lines drawn are 3 and whereas the number of rows and columns are 4, so 3 is not equal to 4. Then we have to go for the next step. What is the next step? Identify the least uncovered value. Least uncovered value here. What is the least uncovered value? 3 is the least uncovered value. X is equal to 3. Now you can subtract all the elements, all the uncovered values by 3, and at the intersection of the lines at these points we are going to add 3. That's it. At the intersection of the points we are going to add 3. That's it. Now then I will go to the next line. So the same values I will take A, B, C, D. Here it is A, B, C, D. Now just write down these values first. So here infinity, 30, 0, and you can subtract 3 from this. What you will get? Infinity, infinite, 30, 0 and 24 minus 3 is 21. Okay. Next, here we can add 3 here, 0, you can add 3 here. So then what you will get? 0, infinity, 13 and 0. 0, infinity, 13 and 0. Okay. Next, here you can subtract minus 3 and this is as it is, this is as it is, you can subtract minus 3. 49 minus 3, 49 minus 3 is 46. This is 0 as it is, infinity, 0, infinity, and 28 minus 3 is 25. and the last row. In the last row, 3 minus 3, you can subtract 3 here. 3 minus 3 is 0, right? Then 4 as it is, then 0 as it is, and infinity as it is. Now scan for the row and column. If you go for row and column scanning and verify if the number of lines drawn, that is the number of zeros covered, is equal to the order, then the problem is optimized, that is optimum solution is reached. Okay, now this is, we can cancel this. In the second row, in this we have 0. In the second row we can cancel this, and in the third row we have this 0 and we can cancel this, and finally what is the 0 left? This is the 0, you can cancel. See the number of lines. 1, 2, 3 and 4. The number of lines drawn is equal to 4, and the order of the matrix is also equal to 4. 4 is equal to 4, therefore the optimality is reached. We can identify, we can match. Now A to C, again B to D, then C to B, again D to A. See, A to C, B to D, C to B and D to A. That means he has visited each and every city only once. A to C, B to D and C to B and D to A. Now just substitute the values, that's it. Now what are the values here? We have A to C, it is 16, then B to D, B to D it is 40, okay. Then next is C to B it is 32, and D to A it is 40. Add this, you will get the answer, that's it. Now this is 6 plus 2 is 8, 4 plus 4 8, 8 plus 1 is 9, 9 plus 3 is 12. So the total is equal to 128, that's it. Therefore the minimum cost is rupees 128, that's it. The minimum cost is equal to rupees 128. This is how we are going to solve this given problem. Let me see. See, very simple concept. Find the least cost of the traveling salesman's method. So just find out the row minima and maximum. Just find out here the minimum value is 46 and maximum is 14. Minimum value is 16 and maximum is 46. Whatever may be the maximum value, just subtract each and every element by 16. That is called your row minima. After row minima, go to the column minima, identify the minimum value in a column and subtract each and every element by that minimum value. That is called row minima and column minima. After row minima and column minima, go for the scanning. Yes, we don't know. Now come to column minima. This is column minima. Go for the scanning. So this is row scanning and column scanning. So in the row scanning, just identify 0. If the 0 is in the row, means complete cancel that particular column. So this is how we are going to perform. Now since here the number of lines drawn is not equal to the number of order, that is the order of the given matrix. So therefore we have to go for the next step. Now identify the least uncovered value. Here 3 is the least uncovered value. Subtract all the uncovered values by 3, and at the intersection of the diagonals, at the intersection of the lines, just add 3. So if you do the operation, then we are going to get a table like this. This is the modified table, that is the iteration. Then just cancel the zeros, and that is go for row scanning as well as the column scanning. Then match. So A to C, B to D, C to B and D to A. So the total cost is 128 rupees. So therefore the minimum cost of the transportation is 128. This is how we are going to solve a TSP, that is a traveling salesman's problem. Okay, hope you followed this. This is also a very important concept. So that's all for today's session. Let us meet with different concept in the next session. Thank you.